Hi, today is Monday, March 30th. We're going to be talking about special parallelograms this week. So we have the rhombus, the rectangle, the square, the kite, and the trapezoid. So today we're just going to focus on the rhombus. And so the question today is, what are the properties of a rhombus and its diagonals? So here are some theorems and corollaries. So rhombus is a parallelogram with 4 congruent sides. So that's it. It's not talking about angles. All it's saying is that, number one, it's a parallelogram, so it has all the properties of a parallelogram. And secondly, it just has 4 sides that are congruent. And then the rhombus corollary is stating that if you have a quadrilateral that has 4 sides, then you have a rhombus. Rhombus diagonals theorem, when you connect the diagonals, they meet at a 90-degree angle. And so all around your rhombus, you have 90 degrees. And then the rhombus opposite angles theorem is that the diagonals are actually angle bisectors. So we already know from it being a parallelogram that opposite angles are congruent, but when you add in your diagonals, it also is splitting those angles in half. And so the 1 arcs, those are all the same angle. And then if you look at the other set of opposite angles, now you have 4 sets of congruent angles as well. So diagonals in a rhombus, they meet at 90, and the diagonals are also angle bisectors. All right, so back to this flow chart. You guys do have this handout, and if you don't have it, I attached it in Schoology, so you can put it in your Notability and look at it. We are talking about rhombuses today. So here's your rhombus, and when you look, if you look backwards, rhombuses are parallelograms, and so they have all the properties of a parallelogram. And then if you head back that way, they're quadrilateral, so they have 4 sides. And then if you head back up, they're parallel, or they're polygons. And so rhombus, all sides are congruent. Diagonals are perpendicular. Check. Diagonals bisect opposite angles. So let's look at this chart. Fill out the rhombus. So rhombus, figure with 4 sides. Check that. Angles add up to 360 degrees. Well, it's a quadrilateral, so check that. All angles are congruent, so that's not necessarily the case in a rhombus. Both pair of opposite angles are congruent. Well, a rhombus is a parallelogram, so that would be true. Only one pair of opposite angles are congruent, not true. All sides are congruent. That is the definition of rhombus. Both pairs of opposite sides are congruent. That is true because it's a parallelogram. Both pairs of opposite sides are parallel. Yes, because it's a parallelogram. Only one pair of opposite sides are parallel. That's not true. Both sides are, or both, there's 2 pairs of parallel lines. Diagonals are congruent. Yes, we just talked about that. Diagonals are perpendicular. Diagonals are congruent to each other. Diagonals, check that. Diagonals bisect angles at the vertex. So the diagonals of a rhombus are also angle bisectors, so check that. Diagonals bisect each other. That is true because it's also a parallelogram. Okay, so let's look at this problem. This is for any rhombus, QRST, decide whether the statement is always or sometimes true. So if we sketch out a rhombus, okay, so I'm sketching out a rhombus, all the sides are congruent to each other, and I label Q, R, S, T, and I'm going to go back and look at my flow chart, and I know a rhombus is also a parallelogram, so I can use the fact that my opposite angles are congruent to each other. And so is Q congruent to S? Well, they are opposite each other. And since a rhombus is a parallelogram, this would be an always. This is always true. Okay, and part B, it says, is Q congruent to R? So if angle Q and angle S that are opposite each other are equal to 90 degrees, then angle R has to be congruent to angle T, which they're going to also equal 90 degrees. So if Q and S happen to be 90, then we know that T and R have to add up to 180, and they also have to be equal to each other. And so what you're going to find, if that is the case, is you actually get a square. So a square is a rhombus, but a rhombus isn't always a square unless it does have 90-degree angles. So this would be a sometimes. Find the measure of the numbered angles in rhombus ABCD. Well, the first thing you should do is label what you know. So you know it's a rhombus. So you know that all these inside angles where the diagonals meet are 90. So right away you know that angle 1 is equal to 90 degrees. You also know that the diagonals are angle bisectors. So all of these angles are congruent to each other. So we'll put a single mark at angle D and angle B because those two are congruent and they are bisected. And those angles that are bisected are congruent. And then angle A and angle C are also congruent, and that diagonal bisects angle A and angle C. So now you have 4 congruent angles. So we're given that we have a 61-degree angle, and we know that the other piece, so ACB, is also 61. And then if we look across at angle ADC, these have to be 61, and BAC has to be 61. Okay, and because we have a quadrilateral, we know all the angles have to add up to 360. So your total angle measure is equal to 360 degrees. And right now we've got 61 plus 61 plus 61 plus 61. So right now we have 244 degrees between angle A and angle C. So if we subtract that, we are left over with 116 degrees. And we know that has to be split up between angle B and angle D. So if we divide that by 2, each is 58 degrees. So this whole thing is 58 degrees. This whole thing is 58 degrees. So angle D is 58, angle B is 58. And if we just want to know what angle 4 is, here, let's add this. So angle 2 is 61. Angle 3 is 61. So angle 4 is going to be 58 degrees divided by 2 because it's the angle is split in half. And so angle 4 is 29 degrees. Okay. Okay, so we're going to go ahead and cross that out and just do this one. All right, so find the measure of the numbered angles in rhombus DEFG. Well, we know that it's a quadrilateral, and so angle, and it's a parallelogram, so angle E is also 118 degrees, and so therefore D and F have to be the remaining. So 118 plus 118 is equal to 236 degrees. If we subtract that from 360, because that's the total angle measure of a quadrilateral, we get 124 degrees. Divide that by 2 because it has to be split between the two angles. Angle D is 62 degrees, and angle F is 62 degrees. We also know that because it's a rhombus, the diagonals are also angle bisectors. So we've got angle EDF and angle FDG are congruent, and then angle EFD is congruent to angle DFG. And so 62 divided by 2 is going to be 31 degrees. And we know that angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. So they're all going to be equal to the 31 degrees.